5D, common denominators. If you remember factors and common factors and greatest common factor, well, common denominator, same thing, where the denominator is in common. Basically, the denominator is the same, such as 3/5 and 4/5. They have a common denominator. The denominator is the same. Now, working with fractions, especially for addition and subtraction, is much easier. In fact, it is only possible if we have a common denominator. But we don't always start with a common denominator. So a very common thing for us to do, to reuse the term common as much as possible, is for us to rewrite a fraction with a different denominator. And I could do that right here. 3/5. Well, what if I want to write an equivalent fraction with a denominator of 20? Well, all I need to do is find out what number I can multiply 5 by to get 20. So 20 divided by 5 is 4. So if I take 5 times 4, I get 20. Then if I multiply the top also by that 4, 3 times 4 is 12. Now you may recognize this as just the opposite of simplifying fractions. With simplifying fractions, we looked for what number can we divide out of both the top and the bottom. We found that greatest common factor and divided it out. Whereas now, I'm saying, well, what number can I multiply both of the top and bottom by to get us to that larger denominator? Let's try another one. 2/9, and I want to write that as something over 36. 36 divided by 9 is 4, so if I multiply 9 times 4, I get 36. And if I multiply 2 times 4, I get 8. Not too bad, pretty straightforward. So that's how we can change a denominator. Of course, the next step in this is, how do we write two fractions with different denominators such that they have a common denominator? What if I have 1/4 and 5/6, and I want to get them so they have a common denominator? Well, it was easy to just say, okay, well, how many times does this go into that, and determine our multiply. But here, again, well, gee, well, what would be a common denominator? I can't multiply 4 by a whole number and get 6. It doesn't happen. So what can I do? Well, one thing I can do is I can find the least common multiple. LCM, least common multiple. So I can look at these and I can say, well, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, right? Or I could just say 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20, right? And what about 6? 6 plus 6 is 12, plus 6 is 18, plus 6 is 24. And then we find the least common multiple, which in this case is going to be 12. And we can call that the LCD, the least common denominator. What's the smallest number that is divisible by both 4 and 6? Well, so we're looking for 12. So if I put this over 12, 4 times what gives me 12? 4 times 3. So 1 times 3 gives me 3, so that's 3/12. And I can want this one over 12. 6 times what gives me 12? Times 2. So 5 times 2 gives me 10, giving me 10/12. So that's one way we can do it. We can find the least common denominator by doing this, by just finding the multiples of each of those and saying, well, what's the smallest one? Another method that you can use is just to multiply the two denominators together. So I can just go 4 times 6 is 24. I had to multiply 4 times 6, so I'm going to do 1 times 6 gives me 6/24. I had to do 6 times 4, so 5 times 4 gives me 20/24. So that's another method. Now, remember what we came out with previously was 3/12 and 10/12. So you do notice that both of these are not necessarily the simplest fractions that would have a common denominator. So although this method will always work, you can always multiply the two denominators together to get a common denominator. Many times that will make you have to deal with a much larger value than you would otherwise. Especially if you have something like 30 and 90. 30 and 90, let's say we have 7/30 and 11/90. If we multiply those two together, 30 times 90 is 2,700. That's huge. I don't want to deal with 2,700. Whereas you may notice that 30 and 90, 3 times 30 is 90. So instead of going up to 2,700 for our denominator and having to multiply 11 times 30 and 7 times 90, I can realize that 90 would be a common denominator. So that's 30 times 3, 7 times 3 is 21/90, and I'm already there. So one option we had was to multiply by the other denominator to get a common denominator, not always in simplest form. Another option was we noticed, hey, we can get, and we went through and we broke up into our multiples and said, okay, well, what's the least common multiple? We use that. Another method we can use is we can bring into play prime factorization again. And I know you may not particularly enjoy prime factorization, but it'll work. 4 gives me 2 and 2. 6 gives me 2 and 3. That's 2 squared, 2 times 3. Common is, well, actually, we go kind of opposite this way. We want to see what we need to be able to come up with both of these values. So that means to get a 6, we need a 2 times a 3. So we need 1, 2, and 1, 3 to get us 6. To get a 4, we need 2 2s. So if we want to be able to get 4 and 6 out of our primes, we need the greatest number of occurrences per. So there were 2, we need 2 here, we only need 1 here. So we need both of these to make sure we can do this. There's 1 3 here, no 3s here. We need to have that in there so we can get this. So times 3, 2 squared is 4 times 3 is 12. And now we find that the common denominator is 12. 4 times 3 is 12. 1 times 3 is 3. 6 times 2 is 12. 5 times 2 is 10. And we get our common denominator. So it's pretty cool. We can do it any number of ways. Again, a variety of options. You don't necessarily have to follow one particular path. Well, let's go back to that example with the 30th and 90th. And I can't remember what I had, so I'm just going to say 7/30ths and 11/90ths. I think that's what I had, but it may not be. Notice what happens with prime factorization. Maybe you didn't notice that 90 was 3 times 30. Well, we take our 30, and that's 2 and 15. 15 is 3 and 5, so we have 2 times 3 times 5. We take 90, that's 3 and 30. That's 3 and 10. That's 2 and 5. Gives us 2 times 3 squared times 5. So now we look at this, we say, well, we need 1, 1, we need 1, 1, we need 1, 2, we need 1, 2, so we need a 2. We need a 3, we need 2 3s. We need a 5, we need a 5. And we find out that our common denominator is 90. So options. We may notice that it's a multiple, in which case we just have to multiply the top and bottom of one of them. We may not, maybe we have to break them into their multiples, and we go, okay, so we got 30, 60, 90, 120, 90, 180, and you go, aha! 90 is a common multiple. Maybe we break it and we do our prime factorization and find out, well, we need a 2, a 3, and a 5. We need a 2, 2 3s, and a 5. So 2, 2 3s, and a 5 gives us 90, gives us our common multiple or our common denominator. So a number of ways to do it.